Algebra 2, what is up? Welcome to your first review video for your midterms that are coming up in about a week. This is topic number 1, characteristics of functions and graph. Just a reminder, you are taking notes on everything, so feel free to pause the video whenever. In topic 1, our important vocabulary is end behavior. This is where the function is approaching both on the left and the right. Remember, the left side of a function is negative infinity, and the right side is positive infinity. Next, we're going to talk about maximum and minimum. This is your highest and your lowest point. Increasing, decreasing, these are the intervals. These are the areas where your function is either going up or going down. Okay, remember when we write intervals, we write with brackets or parentheses, kind of like a point. The first point is where it starts. Number is where it starts. Maybe it starts at 1 and ends at 3. Or maybe it starts at 0 and ends at 8. Okay, we write them in interval notation. They also sometimes might mix and match parentheses and brackets. So 2 to 4 might be an increasing or decreasing interval. Lastly, we got turning point. The turning point is where the function would change directions. So if we had an xy coordinate plane, and we had a function that was going up, and then bounce down, and then bounce back up, your turning points are those points where the function goes from increasing to decreasing, this point right here, or where it goes from decreasing to increasing right here. These are called your turning points. It's like the function is turning around. All right, remember, get this down on your notes paper. We'll be checking for it. Here we go. Let's do some examples, just like the ones you will see on your final exam. So you will see a question on end behavior. It is a multiple choice question, and it will ask you to describe a function's end behavior. So let's just talk about how we write end behavior. End behavior is always written like this. As x approaches negative infinity, f of x does something. It's either going towards positive or negative infinity. The second part is x approaches positive infinity, f of x goes towards either infinity or negative infinity. Remember, the first part of both of these, this first part, and what I mean by that is this: as x approaches negative infinity, as x approaches positive infinity. This just means left or right. We're describing the side we are looking at. So this first one is left side. So our left side is over here. Left, this is negative infinity. Here's our right side. This is positive infinity. So as x approaches the negative infinity, that's this left side. As x approaches positive infinity, that is the right side. So we can see on the left side, our function goes up, and on the right side, our function is going up. That means that our function, this is our function, is going towards positive infinity on the left, and it's going towards positive infinity on the right side. Okay, so let's write our end behavior. Remember, we're going to have exactly what's written up above, except we're going to have to replace the question marks with what our function is doing. So, as x approaches negative infinity. As x approaches negative infinity. So this means left side. So on the left side of my graph, my function, f of x, goes towards positive infinity. My arrow's going up. Okay. First part done. Now we do the right side. So again, we copy exactly as we see. As x approaches positive infinity. So now we're talking about the right side. What is my function doing? My function is going up towards positive infinity. So f of x goes up towards positive infinity. And this is our end behavior for this red function, and we would be done. Let's do one more. So I'm looking at my function. I'm looking at both sides. I see on the left side, negative infinity, my function is going down. So this is towards negative infinity. On the right side, which is my positive infinity side, my function is going up towards positive infinity. So I have everything I need to write my equation. Remember, these first parts, this part right here, and this whole part right here, these will not change. The only thing that is changing is what the function is doing on its ends. So in this problem, we're going to, again, as, ooh, that's a little thick, as x approaches negative infinity, my function, f of x, goes towards, so on the left side, my function is going down towards negative infinity. Now the right side, as x approaches positive infinity, again, I'm just copying it down exactly, always going to start this way. F of x goes towards, and now I look at my graph, on the right side, my function goes up towards positive infinity. And that's end behavior. You'll have a multiple choice question just like this. Remember, I know you don't have graphs, but you can sketch pictures of the graphs, so make sure your video is paused. You have these two examples down in your notes. Feel free to use colored pencils, highlighters, whatever you need, because you will need to know this on the final. All right, next part. Characteristics. So we are going to be given a story and a function, and we just need to answer some questions about that function. So let's make sure we read our problem, and make sure you pause the video and get this written down. Okay, so it's all written down. Characteristics of graphs. Sketch a graph for the following situation. The sun rises at 6. Right here, 6 o'clock, we're rising. It's going to rise to its highest point at noon, 12. It will set at 6 p.m., which is 18 o'clock in military time. And it will reach its lowest point below the horizon at 12 a.m. or 24 military time. So here is our function, and we are asked to do these things. Number 1, when is the sun increasing? So this is asking for when does the sun rise? Okay, my sun is rising. It starts at 6, and it's going to rise until 12. I start at 6, and I end at 12. Because once we hit 12 o'clock, my sun will start to fall. Okay, so I put brackets around this because this is an interval. So it's increasing from 6 to 12. When is it decreasing? So starting at 12, my function starts to go down, 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 and it continues to fall all the way until 24. So I start at 12, and I end at 24. So look, see how we are only using these x values when we're answering these questions. We start at 12, bracket, end at 24, bracket. A and B are done. C, determine the sun's turning point. So this is when the graph U-turns, changes directions, and it's happening one time. Right at noon, you can see our graph switches from going up to down. This right here is called our turning point. This happens at x equals 12. Okay, this isn't an interval because we're just naming one point, not a range of numbers. Okay, let's continue. When is the sun's highest? At its highest. This is the maximum highest point. The highest point is the same as the turning point. This is the highest point. It reaches its max height at x equals 12. E is asking us, when is the sun at its lowest point, its minimum? It is at its lowest point way down here. This is our min. This was our max. This is our minimum because this is the lowest our sun ever gets. It's the lowest point on the graph. Nowhere else on my line does it go under this point. This happens at x equals 24. Last but not least, it asks us, when is the sun at the horizon, or the 0? Our sun's height is 0 whenever it is on the x-axis. Anytime it is on the x-axis, these are called our zeros. This sun is on a 0 twice. Once at 6 and once at 18. These are our zeros. At x equals 6 and at x equals 18. All right, that is your first topic of your final. You have to know your characteristics, these important terms, and you'll be able to look at a graph and pick them. And you'll have to know your end behavior. Make sure you know these two things. Go ahead and flip your page over and start working on the practice problems. Peace out.